Hi friends, in this video we are going to take a look at integral of different questions under completing the square method. So we are going to take a look at the integral of what of the x over 225 plus s squared. Right? So here, since we are having addition here, we can simply say let our x equals to what? The half of this, which is what? 5 tan theta. It's just a constant identity. Understand? So here 5, this 25, I can easily write it as what? As 5 square. 5 square is 6 as what? As 25. So here, if I square both sides, because what I need here is not x, I need what? S squared, right? So squaring both sides, I'm having 5x squared equals to 5 square tan square theta. And don't forget, we need to find an expression for our what? The x. So how can we find the expression for the x? We can easily differentiate this. Differentiating this, we have what? We are having the x equals to 5 sec squared theta. So what others can we do here? We can actually replace everything into back. You can replace everything here into the question, so that we have an integral of the x is what? 5 sec squared theta d theta if you differentiate both sides. So here we have what? 5 sec squared theta d theta divided by, here I'll just put 5 squared here. 5 squared plus, what's my x squared? Is still same as what? 5 squared tan squared theta. So that I can easily rewrite this one as this. This expression I can rewrite it as this: integral of 5 sec squared theta d theta, all divided by, I will factorize 5 squared here into brackets 1 plus tan squared theta. Can you see it? Very beautiful. So what other thing can I do here? I can recall my identity. That's trigonometry identity. We know that our sec square theta equals to 1 plus tan square theta. Beautiful. So I'm having integral of 5 sec square theta d theta divided by what? 5 square sec square theta. Because if I replace this, 1 plus tan square theta is also the same thing as what? Sec square theta. So that I can have this, will reduce this to 1/5, right? So I'm having, let me factorize the 1/5. I'm having 1/5 integral of sec square theta divided by what? Sec square theta d theta. Very sweet. I cannot do use of what is it? I cannot do use of. I'm done with this, because here I can cross it out so that I'm having 1/5 integral what? Of d theta. Then integrating the theta, that means this can cancel this. I'm having 1/5 theta. Theta. So what can I do? I'm having theta here. Okay, I can easily find the expression for theta from my what? From this equation. I know that my x equals to 5 tan theta. Then I can divide both sides by what? By 5. Yeah? Right? This cancels this. I'm having tan theta equals to x over 5. Right? Then let me find value for theta. So theta can actually be what? Be inverse tangent of what? Of x over 5. Yeah. So this expression can be rewritten as what? As 1/5 tan inverse of x over 5 plus c. Then this is the solution to the what? This integral. Thanks for watching. So friends, let's take a look at another similar question I'm having under completing the square method. So this time around, I'm having integral of the x divided by x squared plus 4x plus 13. Yes, very simple. Okay, what can I do with this? Yeah, actually, if you look at this, we are having polynomial of degree 2, which is quadratic equation, right? So here we can easily resolve this. You can use quadratic formula to break this into what? Into smaller parts, just simple chunk, right? But we don't need to stress ourselves. We can actually write this out: x squared plus 4x plus what? Let's put our plus 13 here. Instead of solving it using quadratic formula, we can actually use the shortcut. So here, the coefficient here is what? Is 1. Thank God, it will always be 1. So we're having 1. The coefficient here is what? Is 4, right? So here we are going to find the half of 4, then we square it. That is what I mean is that we are going to find 1 over 2 times 4, or square. Can you see it now? Half of 4, then we square the half of 4. Hope you are following me now. So after squaring the half of 4, we are going to add it here and also subtract it here. Show that here we are having 2 in this, that's what? That's 2 squared, which is also the same thing as what? As 4. So we are going to add plus 4 here and also subtract what? 4 here. Because if we add plus 4 here and also subtracting 4 here, that means we have arrived back to the what? To the normal question. Right? So me adding plus 4 and also subtracting it here doesn't change the value of what? Of the question I'm giving. Can you see it now? So here can actually be what? Can actually be, if you factorize, we can use factorization here. Yeah, we can factorize here. Here will give you something like s plus 2 all square. Right? And this will give you what? Will give you plus what? Plus 9. So I think I should explain how I get my s plus 2 all square. Okay, let me factorize this. I'm having s squared plus what? Plus 4x plus what? Plus 4. So this can actually also be what? S squared plus 2x plus 2x plus what? Plus 4. So this and this marry themselves. I'm having x into brackets s plus what? Plus 2 plus 2 into brackets s plus what? Plus 2. Right? Show that this can actually be what? S plus 2 into bracket was s plus 2. And also it's also the same thing as what? As s plus 2 all square. Can you see it now? I think I've cleared the doubt. So what can I do here? Okay, I'm having plus 9 here and also what? S square plus 9 here. So s plus 2 all square here. If you look at x plus 2 all square plus 9, it's also the same thing as this, right? So if we expand this and also we add 9 to it, it's also the same thing as this, right? Okay, let me verify it here. So I'm having s plus 2 into brackets s plus 2 and also what? Plus 9, right? X times x will give me what? S squared plus what? Plus 2x plus 2x plus what? Plus 4 plus 9. Can you see it? So I'm having x squared plus what? Plus 4x plus 4 plus 9, right? So this will give me what? Plus 13. That's it. It's also the same as what? As this. So do you agree with me that I can replace everything here with s plus 2 all square plus what? Plus 9? Yes. Thank you. So back to the question, I'm having integral of the x over what? Instead of writing this, I'll replace it as what? As this. X plus 2 all square plus 9. So this look exactly as our perfect square question, but not yet. Why? Because here I'm having s plus 2, but I need x, right? I need x or any other variable, but here I can easily replace my x plus 2 with what? With p, because I can do use up. So here I'm having integral of the x over, let's replace this one as p. Let's take this one. Let p equals to what? S plus 2. Show that we're having integral of the x over p squared plus what? Plus 9. Right? Yeah, guys. So, can I do okay? Let me just do normal perfect square. So I'm having integral of the x over p squared plus 9. So I can say let p equals to what? 3 tan theta. Because 3 square is the half of what? 3 is the half of what? Of 9. 3 square is also the same as what? As 9. Then squaring both sides, I'm having p square equals to what? 3 square, which is our 9 tan square theta. Differentiating my what? My this, I'm having the p equals to what? 3 sec square theta d theta. I can easily replace everything here back to the what? To the fourth question. Okay, let me do so. Is there? Yeah, is there. That's a magic. So let's proceed with this. I'm having integral. What's my dx? Oh, I'm having dp. I should replace this one by what? by p, sorry, because I've already said let my p equals to s plus 2. Okay, I should put p here. Yeah, I should put p here because back to this question, I say let p equals to what? S plus 2. So if I find what the p, I will have what? The p equals to what? 1 dx. So my dp is also the same thing as what? As the x, right? So I think I've cleared down. So here I'm having what? My dp, that will be what? 3 sec square theta d theta divided by what? What's my p square? My p square is taken to what? To be 3 square times square theta, but I can take this one first. That's 3 square, which is my 9 plus what? Plus 3 square times square theta. Can you see it now? So which is also the same thing as integral of 3 sec square theta d theta divided by what? 3 square into brackets 1 plus tan square theta. So from my trigonometry identity, I know that my sec square theta equals to 1 plus tangent square theta, right? So I can easily replace it as my sec square theta, show that I'm having integral what? Of 3 sec square theta d theta divided by what? 3 square sec square theta, right? So I'm having integral, I can cancel cross out this and also this, right? So I'm having 1 over 3 abi d theta, right? So I can bring out my 1 over 3. I'm having 1 over 3 integral what? Of d theta, right? So what can I do in this kind of situation? I've already gotten the answer. I'm having this to cancel out. I'm having 1 over 3 theta. Then from this, I can easily find the value for what? For my theta. I'm having p equals to 3 tan theta. Shows that my what? My theta will be what? Will be p over 3 tan inverse. I can write it as theta equals to tan inverse of what? P over 3. Then let me put this back to the expression. I'm having 1 over 3 tan inverse of what? Of p over 3 plus c. Is that the final answer? No, because I must put everything back to the x word because I'm having p here. But the question given to me was in form of what? Of x. So I need to return everything back to x word. Understand? So here I'm having integral of what? Of the x divided by what? S squared plus 4x plus 13, which I also write it as integral of the x over what? Over s plus 2 all squared plus what? Plus 9. So here the answer to this is also the same thing as what? Is 1 over 3 tan inverse of what? Of p over 3 plus c. Then recall, what was the value of what? Of my p. My p is the same thing as what? As s plus 2. So let me put back my what? My p. I'm having 1 over 3 tan inverse of what? Of s plus 2 over 3 plus c. So is that the final answer? Yes. This is the final answer. This is the answer to this problem. Thanks for watching.